Hello dear students. Today we are going to start with next series type of controller, that is static synchronous series compensator, or SSC or S3C. It is shortly abbreviated as S3C compensator, that is static synchronous series compensator. In previous lecture we have covered one type of series controller configuration, that is TCSC. Then we have seen the basic operating principle of TCSC. Then we have seen the three different modes of operation of TCSC. Then we have done the analysis of TCSC, and at last we have studied its advantages. Today we'll start with the next point, that is static synchronous series compensator, or S3C. It is a static synchronous generator operated with an external energy source. In case of shunt, the external energy source is absent, but in case of series, the external source is present. It is a static synchronous generator operated with an external energy source as series compensator, whose output voltage is in quadrature with and controllable independently of line currents. So already we have studied its basic operation in unit number 2. When the line current and voltage are in phase, it mainly controls the reactive power, and for any other phase quadrature, that is when voltage and current are out of phase, then it also controls the active power or real power. So it is a static synchronous generator operated with external energy source has series compensator, whose output voltage is in quadrature with and controllable independently of line current for the purpose of increasing or decreasing overall reactive voltage drop across the line, and thereby controlling the transmitted electric power. It may include transiently rated energy storage or energy absorbing device, just like we have studied in case of static compensator, where we have energy storage source, that is nothing but we have capacitor present in the system. So it may include transiently rated energy storage or energy absorbing devices to enhance dynamic behavior of power system by additional temporary real power compensation to increase or decrease momentarily overall real voltage drop across the line. It is regarded as series connected synchronous voltage source, which can vary effective impedance of transmission line by injecting voltage containing an appropriate phase angle in relation to the line current. That is nothing but by controlling the phase quadrature between current and voltage, we can change the impedance of transmission line and thereby controlling the voltage variations. It has capability of exchanging both real and reactive power with transmission system. If the injected voltage is in phase with the line current, then the voltage will exchange real power. On the other hand, if the voltage injected in quadrature with the line current, then the reactive power is either absorbed or generated will be exchanged. So this is the basic diagram of S3C, where it is shown the energy storage device present in the system. This S3C is nothing but a converter which is connected to a line through injection transformer. It consists of multi-phase voltage source converter with a DC energy storage device as shown in figure. Here the controller is connected in series with the transmission line. So this is nothing but is connected in series with the transmission line. Whereas in SATCOM it is connected in parallel with the transmission line. Principle of operation: a S3C compensates the transmission line inductance by presenting a lagging quadrature voltage with respect to transmission line. That is nothing but when the voltage lags behind the current, or the current lags behind the voltage, it compensate the transmission line impedances. This voltage acts in opposition to the leading quadrature voltage appearing across the transmission line inductance, which has net effect of reducing the line inductance. In addition to S3C, the S3C can be gated to produce an output voltage that leads the line current by which provides additional inductive reactance in the line. So just by controlling the firing angle of the thyristors or S3C, we can control the output voltage that leads the line current. If the voltage of the S3C leads the line current, then it gives additional inductive reactance in the line. This feature can be used for damping power swings and if the converter has adequate rating for limiting short circuit currents. A series compensation scheme is shown in below. So this part is connected in series with the transmission line through injecting transformers, and we have control over here. The controller comprises of voltage source converter in which its coupling transformer is connected in series with the transmission line. The converter side voltage rating is higher than the line side voltage rating of the injection or coupling transformer to reduce the required current rating of the converter switches. The other side converter or the converter side windings is delta connected to provide path for third harmonics to flow. The basic DC voltage for the conversion of AC voltage is provided by capacitor, and the DC-AC conversion is achieved by PWM technique, that is applied to the converter. A DC capacitor rating is chosen to minimize the ripple in the DC voltage. Since we have energy storage device which can be a DC, and since the DC has higher ripple contents, so this can be minimized by connecting the capacitor of higher value. An important aspect of S3C is that it does not introduce any physical capacitor in line. It does not cause SSR. However, it assists in damping of SSO, that is nothing but oscillations caused by either series capacitor inserted in the transmission network. The subsynchronous oscillations. The SSO is nothing but subsynchronous oscillation. It damps out the subsynchronous oscillations may be caused by interconnection between the generator torsional system and the series compensated transmission lines. These oscillations, usually in the frequency range of 10 to 50 Hz, can potentially damage the generator shaft. So it is important to damp out these subsynchronous oscillations.